The universe has a history of around 13.7 billion years, yet it remains a realm of mysteries that astronomers are still striving to uncover. Cosmic anomalies are plentiful, ranging from dark energy to cosmic rays to the unique characteristics of our solar system. Humanity has barely ventured beyond our moon, and only Voyager 1 and 2 probes have ventured beyond our solar system. A significant portion of our understanding of outer space comes from studying falling objects and observations through telescopes. While some events seem to suggest the involvement of other living forms, most are scientific wonders never seen on our tiny planet. Let's explore some space mysteries that have puzzled even experts. Number 1. Zombie satellite. When it comes to exploring space and providing vital services, satellites are irreplaceable. At any given time, thousands of satellites, both active and decommissioned, orbit the Earth. Some satellites meet their end during re-entry into the Earth's atmosphere, while others remain in orbit long after their primary missions have concluded. These satellites, abandoned due to operational issues, are often referred to as zombie satellites. Due to their operational failures, these satellites are often forgotten and continue to roam the skies, earning them the name zombie satellites. Not all of them are entirely defunct, as sometimes a connection can be restored upon rediscovery. Before we delve deeper into the topic of these wandering satellites, let's take a trip back to the Cold War era. During the Cold War, as America transitioned from Korea to Vietnam, obtaining timely and reliable global intelligence was crucial for the U.S. military. While the U.S. military could reach almost any location worldwide within hours, reliable long-distance communication posed a significant challenge. Effective communication was essential between various military branches in the air, on the ground, and at sea. Command and control communications were necessary to support communications on the move with aircraft, vehicles, and vessels. In the early to mid-1960s, there was no single tactical communication system capable of meeting these needs. The demand for global military communication drove the development of today's communication satellites. The plot begins with the inception of the Tactical Satellite Communication Program, TSCP. In early 1965, the TSCP reaffirmed its commitment to tactical satellite communications worldwide. To achieve this goal, the U.S. Air Force launched a project to provide low-rate digital communications for airborne units using UHF satellite frequencies. In collaboration with the Aerospace Corporation, the Air Force Project Management Team conducted an experiment to test UHF satellite communications. To ensure a solution that could function in the woods and adverse weather conditions, they sought assistance from the MIT Lincoln Lab. Lincoln Lab, already under an Air Force contract, made conceptual adjustments that led to the creation of an experimental satellite to be launched by a Titan 3C launcher. The communications equipment included a commercially available teletype, airborne transmitters with a 1,000-watt output, and compact solid-state receivers. In addition, special antennas and sensitive equipment were developed and integrated into the satellite to measure and report interference. Thus, the Lincoln experiment gave birth to satellite number 5, affectionately dubbed LES-5. In June 1967, the satellite was delivered to Cape Kennedy, Florida, where it was slated for launch alongside 5 other satellites. On July 1, 1967, LES-5 was launched atop the Titan 3C space booster. After demonstrating 100 words per minute teletype voice and facsimile communications, the satellite was made available for research and testing by universities. Meanwhile, the military had moved on to a larger, more potent LES-6 satellite. Upon concluding the tests, the LES-5 satellite was supposed to be deactivated by its one and only battery, assigned the sole task of powering it down after 5 years. Interestingly, this battery seemed to be the only component of the satellite that did not function. Lost to memory, LES-5 was eventually rediscovered on March 4, 2020, after 53 years in space, despite being intended for a shutdown 49 years earlier. Encouraged by another satellite hunter's discovery of ALIAS-1 in 2016, Tilly took it upon himself to find LES-5. A shelter-in-place order due to the coronavirus pandemic provided him ample time to search for this needle in a haystack, as he recounted on his blog. On March 24th, he identified the signal of the LES-5 satellite at 237 MHz and shared the news on Twitter. "Well, folks, here's what appears to be a new zombie set." As he continued to take measurements and study this ancient elusive satellite, a significant revelation awaited him. Not only was LES-5 still active in Earth's orbit, but its radio had evidently defied the planned shutdown in 1972 and was continuously operating, powered by attached solar panels. This implies that, despite the passage of time, there remained a good chance of eventually restoring communication with the satellite. While the satellite continues to generate data, decoding it poses quite a challenge, as documentation for the satellite likely disappeared long ago. Interestingly, the laboratory responsible for the satellite's development has remained silent regarding its sudden resurgence, leading to speculation about its potential involvement in top-secret military research. Despite years of radio silence, the zombie satellite seems to have some surprises in store. Number 2. The James Webb Space Telescope. Glimpsing through cosmic dust for an extraordinary view of a black hole. Black holes are the ultimate cosmic sinkholes. When a massive star collapses, it implodes into an area of such intense gravity that even light gets swallowed. The James Webb Space Telescope now unveils an unprecedented view of a distant black hole, peering through layers of dust to study the structure and composition of the material swirling around this massive entity. Webb's Near-Infrared Spectrometer, NIRSpec, recently focused on a supermassive black hole at the center of the topmost galaxy visible in Webb's image of Stephan's quintet. Spectrometers segregate light into various wavelengths, and as different elements absorb light at specific wavelengths, the resulting spectrum allows scientists to discern the chemical composition of the emitting or transmitting substance. Since NIRSpec operates in the infrared range, it successfully obtained a spectrum from the supermassive black hole, even in the presence of stardust. Through Webb's lenses, the supermassive black hole appeared in wavelengths never observed before, corresponding to atomic hydrogen, molecular hydrogen, two hydrogen atoms bonded together, and electrically charged iron ions in the surrounding gas. Combining these elements, scientists were able to map the structure of gas streaming into the black hole to be consumed, as well as the gas outflows expelled by tremendous radiation jets formed through the intense compression of swirling gas and dust around the black hole. Astronomers have also detected a cluster of galaxies merging around a rare red quasar, a gargantuan supermassive black hole voraciously consuming gas and other matter. An international team of scientists made this astonishing discovery while peering back billions of years through the James Webb Space Telescope. The discovery presents a unique opportunity to study the early collisions of galaxies that contributed to the formation of the universe we know today. According to experts, this intensely bright and reddish quasar is approximately 11.5 billion years old and stands as one of the most potent ever observed from such a vast distance. Described as a black hole in the making, this phenomenon was previously identified in scans of this region of space using the Hubble Space Telescope and the Gemini North Telescope in Hawaii. However, it was not until later observations with JOST that not one, but at least 3 galaxies were revealed to be revolving around the quasar. JOST's images further unveiled that these 3 galaxies were moving at extraordinary speeds, indicating the presence of a massive mass, and leading scientists to believe this could be the most densely populated area of galaxy formation ever observed in the early universe. While these findings have surprised the scientific community, there is no cause for concern. Throughout history, major technological advancements in astronomy and other fields have led to significant periods of scientific discovery. Presently, it feels like we are in one of those transformative moments, and today's discoveries may lay the groundwork for future breakthroughs, even if they take decades to materialize. In reality, such discoveries indicate that the JWST is fulfilling scientists' expectations by unveiling fresh and thrilling information about our vast cosmos, addressing old